Hello students, how are you all? I hope you all are fine and doing well. So in last lecture we have started the Klemper circuit, right? And I have told you the basic operation of those Klemper circuits, right? I have told you that whenever there is a input and if we add some DC supply in it, then the output will be shift like this. If it is shifting in positive side, then it is called positive clipper. If it is shifting like this in negative side, then it is called negative shifter, right? Or you can say negative Klemper circuit, right? Now here in Klemper circuit I told you that peak values and average values will be changed, but what is not changing, then RMS and peak to peak is not changing. This two is going to change, this two is not going to change, right? The another thing I told you that the input, or you can say charging time constant, CRF, should be much more or less than the discharging time constants, CRF, right? And keep it in mind that the designed rule for RC time constant, designed rule for RC time constant is greater than or less, it means RC should be greater than 5 times of input time cycle, right? It must be greater than 5 times of the input of time cycle, right? Okay. So this is the basic thing that we have learned in the previous lecture. So today we are going to start with the positive Klemper. I have told you and I have repeated these rules because these rules are going to be used in this Klemper circuit everywhere, right? Okay. Let's start. Here we are using a positive Klemper circuit, right? So in positive Klemper circuit there is a capacitor, here there is a diode, and here there will be a resistor Rm, right? And across the resistor you are going to get the output voltage V0. Here this is V in, right? This capacitor, this one is diode, right? Okay. Suppose at the input you are giving like this. This is the input Vi, and at the input you are going to give like this. So it is 0, 5 plus 5. Minus 5 volts, right? But at the output what will you get? At the output you will get like this. Right? So here it is 0, here it is 5, it is 10. Why? Because it is a positive Klemper circuit, so your waveform or input supply will be shifted upward direction, right? Now what will happen, as I told you that here RC time constant for charging RC time for constant for the charging and discharging is also dependent, right? So you can say RC time constant for charging is less, RC time constant for discharging is large, right? And due to that, while charging it will take less time, but while discharging it will take greater time, right? Now suppose કે આપણે આ input time આ ભાગ positive છે. Suppose this part is positive, this part is negative. What will happen? Here you are when just giving supply at that time that diode is in reverse bias condition, right? And when it is the reverse bias condition, what will happen? This diode will work as a open circuit condition, right? And what will happen? Okay, let's see. First, we are just taking the negative cycle. This negative cycle. First, suppose this one is negative, this one is positive. What will happen? Current will flow like this. Why? Because this diode D is in forward bias condition at this time. But when this type of current is flowing at that time, capacitor C is getting charged. Capacitor C is getting charged, right? હવે કેપેસિટર C જે છે એ ડાયોડ મતલબ ચાર્જ થવાનું ચાલુ થાય છે. Now see, capacitor is charging through this diode and resistance of this diode when it is in forward bias direction it is RF. So you can say the time constant during charging process is CRF, right? Now what will happen? Capacitor is fully charged, right? At the output કોઈ પણ જાતનો કરંટ અહીંયાથી ફ્લો થાય છે નહીં ને. So at the output current is 0, but capacitor voltage VC equals to VM. એટલે કે એના મેક્સિમમ વોલ્ટેજે એ કેપેસિટર ચાર્જ થઈ ગયેલું હશે. Now what will happen? When this one is positive, this one is negative, at that time this diode will work as a, now suppose પહેલા જ્યારે આ બાજુ કરંટ ફ્લો થતો હતો ને ત્યારે પોઝિટિવ ના નેગેટિવ હતું, right? Now what will happen? Now I'm just going to remove this arrow, right? Okay. Now this one is positive, this one is negative, this diode is in reverse bias direction, and because of that it will work as a open circuit condition like this. There will be no branch in between them. Now what will happen? See, input VI equals to VM. Why? કેમ કે કેપેસિટર હંમેશા જેટલા ઇનપુટ વોલ્ટેજ હશે એટલે ચાર્જ થઈ જતો હશે, એટલે approximately VM, right? Capacitor VC equals to VM, right? Now what will we do? Just take a KVL, right? just KVL apply કરીએ આ લૂપ માટે, આખી લૂપ માટે, then what will happen? VI equals to minus VC, કેમ કે અહીંયાથી માઈનસ ની સાઈન આ બાજુ plus V0, right? Now VI equals to, तो क्या VI equals to VM, VC equals to, तो क्या VC equals to VM, V0 આ માઈનસ, right? V0 equals to VM, this minus ને આ બાજુ લઈ આવીએ તો પ્લસ VM equals to 2VM, એટલે કે સાયકલ જ્યારે ચેન્જ થશે, પોઝિટિવ સાયકલ હશે, at that time it will has the maximum amplitude 2 times of the input નું કેટલું હતું 5, એનું 2 times એટલે કે 10 જેટલું એને એમ્પ્લિટ્યુડ મળશે. સમજમાં આવી ગયું, રાઈટ? બહુ જ ઈઝી છે, રાઈટ? ટેક અ સ્ક્રીનશોટ, જલ્દીથી સ્ક્રીનશોટ લઈ લો. Okay, take a screenshot first. जल्दी से स्क्रीनशॉट ले लो. Okay, नेगेटिव ની વાત કરી લઈએ. નેગેટિવ માટે કઈ રીતના કામ કરશે? Okay. Now, negative clamper circuit, right? In negative clamper circuit diagram is like this. This is capacitor, diode will change its direction, and here it is RL. Here we will get the output, that is V0. Here RL, this one is diode, this one is capacitor, it is input, right? Okay. Now in negative clamper circuit we are going to give input like this. This is VI 0, 5, minus 5 volt. In negative clamper circuit, all the input waveform will be changed, or you can say shift downward like this, right? This one is 0, minus 5 volts, minus 10 volts. So this one is the output waveform of the clamper circuit, right? Now let's see how it will work, right? So suppose at the positive half cycle, for positive half cycle, positive half cycle માટે શું થશે? તો positive half cycle માટે આ part positive, this one negative. What will happen? This diode is in reverse bias, so forward bias, diode is in forward bias. Capacitor is charging, capacitor charge થવાનું ચાલુ થશે. કેમ કે કરંટ નો ફ્લો આ રીતના થશે, રાઈટ? કરંટ નો ફ્લો થવાને કારણે what will happen? જો કરંટ RL માંથી પાસ થતો નથી, that is why V0 is 0. કેપેસિટર ના અક્રોસ ના વોલ્ટેજ તો કે VM જેટલા થશે. હવે કરંટ અહીંયા ચાર્જ આ રીતના થાય છે, જો પ્લસ માઈનસ, કેમ કે કરંટ એન્ટર આ ડાયરેક્શન થી થાય. So this side is positive, this side is negative, right? આઉટપુટ માં 0, જો આઉટપુટ માં 0 બને છે પોઝિટિવ હાફ સાયકલ વખતે, યસ 0 બને છે, રાઈટ? Now, negative half cycle. Negative half cycle વખતે this one is negative, this one is positive. Now, this diode is in reverse bias કેમ કે current આમ flow નહીં થઈ શકે. Now what will happen? See, આ minus અને આ minus બે એક સરખા થઈ ગયા. Done. Current નો flow આ direction માં થશે. And that is why output voltage કંઈક મળશે. કેટલા મળશે? તો KVL લગાડીએ તો VI equals to કેટલા થશે તો કે minus VM minus V0, right? હવે શું થશે જલ્દી કહો શું બનશે જલ્દી ઓકે VI એટલે અહીંયા VC હોવું જોઈએ ને હા VC ઓકે VI એટલે તો કે તો VM જેટલા જ થાય કેમ કે ઇનપુટમાં V જેટલા હોય એટલા જ એપ્રોક્સિમેટલી કેપેસિટરની અક્રોસમાં વોલ્ટેજ બને એટલે રાઈટ તો VM minus VM minus V0 આ V0 નું સામે લઈ જાવ એટલે V0 આ VM નો ઓલી બાજુ લઈ જાવ એટલે VM minus VM તો VM minus 2VM right so જો નેગેટિવ હાફ સાયકલ ટાઈમે એની વેલ્યુ -2VM એટલે કે 5 ના ડબલ એટલે કે 10 વોલ્ટ જેટલી બનશે રાઈટ બહુ જ ઈઝી છે કઈ છે નહીં આની અંદર મેઈન KVL લગાડતા તમને જો આવડી જાય તો કઈ રીતના કામ કરવું it will be easy take a screenshot જલ્દીથી સ્ક્રીનશોટ લઈ લો okay I hope you have taken the screenshot. So, we will going to over this lecture here. જો કઈ પણ ડાઉટ હોય તો કોલેજના નંબર પર કોલ કરીને પૂછી લ્યો અને બીજું કે જે પણ કરાવેલું છે એ બધું તમારે રેફરન્સ બુકમાં જોઈને તમારી ફેર બુકમાં લખવાનું થશે એટલે બધું કમ્પ્લીટ કરતા રહેજો ગમે ત્યારે તમારી બુકને હવે મંગાવી દઈશ રાઈટ ઓકે થેન્ક યુ સો મચ એન્ડ હેવ અ નાઇસ